been taking this course from Gilbert Strand. I don't know which one is it. Okay, so here is the camera. From Gilbert Strand, the 1806 course at MIT on linear algebra, and I liked it very much. So that's why I would like to walk you through the first problem set of this course. So it's a live thing. I haven't done anything beforehand. We have the problems on the screen. I found them from a website, an MIT website. I don't know the link. I'll put it in the description. And we also have the solutions. I haven't looked at the solutions yet, and I'm gonna look at the end of this live stream. So if we arrive at the end of the problem set until the end of the live stream, I'm happy, but the live stream would be an hour long maximum, because if it's more than an hour, then it's too long. We will break it up into parts. So let's start. So first problem is 10 points. I can't read from here. Let's see. Take my glasses. First problem is 10 points, and we need to express B as a linear combination of V1 and V2. Okay. And V3. Okay. So a bit of theory before we start. What's if you hear someone from outside, it's the neighbors who are playing. So a bit of theory. What is a linear combination? A linear combination is when a vector is multiplied, subtracted, or so linear combination is when a vector is multiplied by a scalar, or when a vector is subtracted from another vector, or when a vector is added to another vector. So that those are all linear combinations of vectors. So let's take an example before we start. Let's take 1, 2, 3. We aren't going to go into spaces and subspaces, but so this is a vector. Let's say v equals 1, 2, 3. Yeah, and if we have a v, so a times v is equal to, we know how to multiply a scalar by a vector, so, or a vector by a scalar. A times 1 here is a times 2 here is 2a, and a times 3 is 3a. Pardon my English. Okay, so that's a linear combination. If we take this to the matrix level, let's say that this is matrix A. 1 second. So this is matrix A. 1, 2, 3, 4, 5, 6. This is matrix A, and we need to we want to take the linear combinations of this matrix to get a vector. So we know by the rule of multiplication that if matrix A has sizes m times n. By the way, all of the things I learned is from the OpenCourseWare thing on the OpenCourseWare course on OpenCourseWare from Gilbert Strand, the fall 2011. Yeah. Okay. So if you want to learn more, please head there. So if A is of size m times n, you may see this if you are programming. You may see this. The shape of the array is m times n, and so we want to multiply it by b. Then b needs to be n times b, or p. Let's p. N times p. And the result the result would be of size m times p. It's all in the course, so you need to head there if you want. Okay, so this means that we need to have the number of columns of this matrix should be the same as the number of rows of the second matrix. So A is 3 by 2 because it has 3 rows and 2 columns. I think that's it. Yeah, and times x, we know ax equals b, so times x, which needs to be 2 times something, and we, as we can see in the thing that in the exercise, we need a vector here. So b needs to be of shape 3, 1. It's a row vector. So that's why x needs to be of shape 2 and 3, 2 by 3. Okay. So we need to multiply this by 2 by 3. Actually, we might just need to, oh wait, so wait a second. If you just bear with me for a second. So if we take something simple and we just take a vector here, x1, x2. Okay, so what's, because we are on the subject of linear combination, then this product would be x times the first column here plus x2 times the second column here, and we're gonna add them, so hence the plus, and it will be 1 times, so x1 2x2 3x3 3x1. Oh, okay, so I'm no, so it will be this, make it, so it's x1 plus 4, so this is the last vector, 4x2 2x1 plus 5x2 3x1 plus 6x2. Okay, so why is it a linear combination? Okay, so you can see, wait a second, I'm gonna switch to the better view. Why is it a linear combination? It is a linear combination because we are multiplying by a constant. Okay, so a line is just the multiplication of a variable by a constant. So let's get back to the problem. Now that we know a bit about linear combinations. I don't know if my examples are clear. You can understand something, but I hope you do. So 10 points for the first problem. 1. Express b equals -1 -2 7. Okay, and we have 3 vectors, v1, v2 and v3. Well, we know that we can combine these 3 vectors in a matrix, a 3 by 3 matrix, because we have 3 rows per vector and 3 vectors. So A, can you see? I think we can. A is equal to 2, 4, 4 minus 3 minus 6, 3. So 2, 4, 4 minus 6. Oh no, minus 3 minus 6, 3 minus 3 minus 6 and 3 and 4, 10, 10. You can't see, but okay. So what do we need to solve? We need to solve a times x equals b. That's the equation. So let me write it right. It's the most important one. So a x equals b. Now we know from the shape thing I just told you earlier that we need the B matrix. The B vector is of shape 3 1. So this is 3 1. Well, not like this, but okay. The shape. You understand me? The shape is 3 1. A is 3 by 3. So we know by the rule that x must be 3 and then something, and the something is the second dimension of b, which is 1. So x needs to be of shape 3 and 1. Okay. I don't know if it's a great idea just put this here. There's anything. Okay, no, so it's on the part. Yeah, this is better because now you see more of the board. Okay. So 3 3 3 1 3 1. Great. A, we know what it is. B is this. So if you look at A, we need to multiply the first column here by. So again, we have 3 x's. So by x1, and the second column by x2, and the third column by x3, and we need to add them up at the end. So x1 is 2 4 4. Here we have minus 1 minus 2 7. And if we would just add x1 and x2, we have minus 3 plus 2, which is minus 1, minus 6 plus 4, which is minus 2, and 3 plus 4, which is 7. So we know that x1 needs to be 1 and x2 needs to be 1. Why? Because we multiply 1 by each of the numbers here. So x3 needs to be 0, because if it's something else than 0, we'll have other values here. There might be more solutions to this, but I think the first one is this one. And since we need only one linear combination, I think it's better if we just stick with this one. We could calculate some ratios and include the 4 in here, but this one is the simplest. So we have A times, actually, yeah, okay, so the answer to the first thing is A times 1 1 0 equals minus 1 minus 2 7. That's the answer to the first question. I don't know where to save it, so let me just write it here. I know you can see it, that's the point. I'm writing it there so I can save it for the solutions when we check the solutions. Okay, so first problem is done. How much time did it take? Oh, 15 minutes. Okay, that's a lot. Now, second problem. Second problem is find any numbers y and z such as a times yz equals 1 2. Okay, so again, we know what linear combinations are. So A is 1, 2, 3, 4. And what you may notice about A is that it's symmetric, so the transpose would be the same. 1, 2, 3, 4 times YZ, ZY, YZ times YZ equals 1, 2. Okay, so I think it's pretty much straightforward. We have Y times the first column plus Z times the second column. What's the answer? So we know this B it equals the first column of A, so Y needs to be 1 and Z needs to be 0. Any numbers, so it's not all the numbers. I don't know if you if my voice is too loud. Yeah. So any numbers, not all the numbers. I mean, we found. So for the first question is 1, 0. So is it 2A? So 2A equals B equals 1 equals 0. 2B, we need to do the same thing, but now what's changed is that A times YZ needs to be equals to 0. I suppose 0 is a vector, because if it's not a vector in the same vector space, I haven't learned how to turn a matrix into a number, because if you multiply a matrix by a scalar, it will just so by the rule of multiplication, a scalar isn't a vector, so we don't apply the rule of multiplication, so it will just multiply each number by the scalar. So I don't know how you can turn a matrix into a scalar, but the point is we're gonna assume that this is the 0 vector, so 0, 0. Now find numbers. So I don't know if it's all numbers. Okay. We know that if we put y equals 0 and z equals 0, this is a solution, because everything multiplied by 0 is 0. Then, if we I don't know, just 1 second, I don't know if I'm right or wrong, so don't take this for do it yourself before. I'm just a student who does this because I enjoy it, but I'm not qualified in any way to tell you what to do. Okay, so the string is on top. I thought it was. So 0, 0, it's a solution. Then you see that this matrix is not invertible, because we have the second column is a combination of the first column, so it's 2 times the first column. So we know z is 2 times y. So what we could do, actually no, I've said something wrong. Z is not 2 times y, but what we could do is set z as minus 1/2. So y equals 1, z equals minus 1/2. And this should work. And then we could just multiply this by a number. So if we have times 3, so y times 3, and so if y equals 3, then actually let's do 2, so we can see the pattern here. Z equals minus 1. If y equals 3, z equals minus 3/2, and so on. So if you multiply a number here, you need to multiply it here because they are proportional. Let's test for minus 1. So y plus 2, yeah, this one works, this one works, and since they're proportional, there is an infinity of numbers that work. Okay, so I'm gonna put 1 and minus 1 half. Actually, I'm not gonna put it because I know I'm right. I think, or I'm right, or I'm terribly wrong, and I didn't understand anything of the course. But I don't think I think I understand something. So see, if a times y z equals 0, then explain why we must have y z equals beta times 2 minus 1. 2 Oh, so that's actually I did the C question moments ago. Why do we need to have beta times 2 minus 1? Because, as I said, if y equals 2 and z equals minus 1, and we multiply them by beta, which is a scalar, this is since they are proportional, for we must have beta there because it works. I don't know why. Oh, why we must have beta? Because they are proportional. That's why. I think I don't understand the question, but okay. I'm gonna skip it. It's too simple, or I'm too dumb. So take the numbers from part A. This question to part A, which was y equal 1 and z equals 0. So y equals 1 means 0. Okay. Without any calculations, explain why A times this matrix equals B. Wait 1 second. So y is 1 and z is 0. So A times the matrix is 1 plus 8 and minus 4. So 9 minus 4. Let's see. Equals B. Why is it equal to B? Because, as we saw earlier, there needs to be, so if y equals 1, for them to, so it needs to be equal to B, and let's rewrite B, which was, B was 1, 2. Explain why this equals B without calculations, but that's hard. Without any calculations, explain why this equals B. I mean, I need to do the math to explain why, but let's see. So I think they are referring to the fact that there needs to be a proportionality constant. So 1, 0 works. What other number works? Let's see. If we do it like times 2, no, times 3 minus 1. So y equals 3, z equals minus 1. You see why it equals minus 1? Because 3 times this is 3, 6 minus 2 is 1, minus 4 is 2, and then they are proportional, and there must be a line here that you can take the slope of with calculus. So let's actually let's just take the ratio. Wait, no. So let's put y as the input and z as the output. So we have the slope of a line is the difference of the outputs over the difference of the inputs, which is 2 over 1, which is not good. No, so it's 1 minus 3, so it's minus 2 over 1, so it's minus 2. Right. 3 minus 1 over minus 1 minus 0 equals minus 2. So this means that if we multiply y by minus 2, we get okay, and then there must be an x. So I'm wrong. So this is the coefficient of our line, and then the y-intercept is ax plus b equals nothing. So ax plus b equals 0. So that means that a is minus 2 times x, which is 1. So plus b equals actually 0. So b needs to be equal to 2. And then if we try with this, so it would be minus 2, so minus 6, minus 2, they are not proportional. Minus 6 plus 2 is minus 4, and y is minus 1. Yeah, they are not proportional. I don't know how to answer this question. Without any calculation, explain y plus 8 z minus 4. So plus 8 minus 4 plus 8 minus 4. I don't know how they expect me to do it without any calculations, so I don't understand the question. I don't understand the question. Well, how? So 0. So no, y is 1. So 1 plus 8. Yeah, so it's 9 minus 4. 9 minus 4. It will be 9 of this. So 9 and 18 minus 16 is 2, and 9 minus 8 is 1. I don't know. It's because they obey the function we found, but I don't think that our function is linear. I don't know how to approximate even more data, but okay. Yeah, so skip this one. Then the third one, 15 points, compute 3 by 3 matrices M1, M2, and M3, where M1 equals this and 2 equals this. I mean, except the third, the question before, so the last part of the second question, the homework is pretty easy, I think. Maybe I'm terribly wrong. 2 times 2 minus 1, 3. Okay, so how do you think about this without any calculations? I mean with calculations, but intuitively. What you need to do is put in the first what will be the shape of M1. So we know this is 3 by 1, 3 by 1, and this is 1 by 3, pardon me. So M1 would be 3 by 3, because it's this one and this one. Okay, so 3 by 3, this means that M1, so this thing here tells us that we need to put in the first row, we need to put this thing times 1, so it will be just this thing, 2 minus 1 and 3. Then in the second row we need to do the same, with 2 minus 1 and 3, and the third row we need to do the same, 2 minus 1 and 3, and that's our M1. Okay? One second. I wish I could pause this live stream, but I can't. Okay, M1. Then M2. I'm gonna finish with the third question because I need to go. So M2 is 0, 1, minus 3. And after this 0, 2, minus 1. Okay, so what this means is we have M2, which is a 3 by 3 matrix, and it's 0 from in the first row. It's 0 times this, so it will be just 0, 0, 0, 0. Then it's 1 times this, which is 0 times 1. Here is 1 times 2, so it will be 2 minus 1. And here is minus 3, so it will be 0, minus 6, 3. This is M2. Then M3, 0, 0, 1, 0, 0, 4. Okay. 0, 0, 1. 0, 0, 4. I hope no one at MIT would watch this video because I hope they understand me in class. So, 0 times 0, 0, 4 it will be just 0, 0, 0. Same for this one, 0, 0, 0. And here it will be 0, 0, 4. So that's the matrix. Okay. That's it for today. Let's just check that we had everything right. So I don't know if you can see, but this is a website. You can't. Solutions. Okay, so these are the solutions. Many ways to. So one is 1, 1, 0. Let me just point you. I don't know if I can. What was the answers? This is where I put them. So first one is 1, 1, 0. Okay, that's the same as ours. The second one is 1, 0, 2 minus 1. We did the same thing. If a y z equals 0, so then my equation 1, okay, is the c I don't know. I will check it later. But okay, so the c just tells us that they are proportional. So a y plus 8 equals a. Well, those are calculations, so I don't know what they told me about no calculations. Okay, let's pass. So third one, we did it right, as you can see. And then I'm not gonna see the rest of it because it's another exercise. Okay, so see you.